Alright, CNT120 Chapter 4 Lab. We're on Part 8 on trace. We're going to use the trace command through our network. So trace is handy. This actually shows you the path that a piece of data takes from, source to destination through a network or a series of networks. Now, where this can become handy, let's say I'm troubleshooting or I'm managing a network like Hack, and I'm worried about communication between, the Harrisburg site and the Lancaster site, or the York site and the Gettysburg site, that sort of thing. I should kind of know in my brain what path my data is taking. Normally, if I run a trace and I see that path, good, everything's functioning. If I run a trace and I don't see that path, or it stops partway, this is a clue as to maybe where the problem is. That's where this becomes handy. So trace is showing that path we're taking from A to B, and if I know what things should normally be, and I don't get that, it's a clue as to where there might be a problem. So we're going to, in this network, we really only have one path from over here to over here, but we're still going to trace it and see that it's hitting this router, etc. So I'm going to go Harrisburg PC to the Philadelphia PC is what I'm going to do. So on the, I'm going to open up the Harrisburg PC desktop command prompt, and I'm going to issue a trace over to Philadelphia. So I'm going to look at the Philadelphia PC here. I'm just going to hold the pointer over, and I see right now it's 3176. Now, yours might be different because if you remember, I'll go to the Philadelphia PC here. This is DHCP. So yours might be 175, 177, 178. That's fine. Use whatever yours happens to be. So in this case, mine is 3176. So in the Harrisburg PC over here, I'm going to open up my command prompt, and I will do a trace RT to 192.168.30.176. That was the address of the Philadelphia PC. In a Windows command, it's trace RT for route, trace route. What I see is the first thing it hit was the 10.1, which is this router up here. That's what that is, that router right there. Then it hit 20.2, which is this router right there. And then it hit 3176, which is this PC. So from the Harrisburg PC, it went boom, boom, boom. Which, again, is not too eventful because there is only one path. But if I do have a large network of possible paths, this is showing me at this instant in time, it took this path to get from A to B. If I do it again a little bit later, if there's multiple paths and I do it again a little bit later, it might take a different path because there's maybe less congestion on that other path. That is possible. So here is my IP4 trace between the Harrisburg PC and the Philadelphia PC. So I'm going to copy that. And I'm going to go here to my text file. I'm going to say part 7. Well, excuse me, part 8. Let me get it right here. Part 8. And this is trace. And I'm going to paste in my IP4 trace. And you know us, if we do IP version 4, we're going to turn around and do IP version 6. So to do IP version 6, I need to do it between my laptops because they're the ones I left the IP version 6 addresses on. So what I'll do to make my life a little easier, I'll go over here to the Philadelphia laptop. I can hold my pointer over to see the IP, but I'm just going to open it up, and I'm going to go in here to IP config, and I'm going to carefully copy that out. I'm not going to do anything to it. I'm just going to copy it out. I'm going to close that. I'll go to the Harrisburg laptop, open it up, and again I'm going to do trace RT, and I will paste in that address, and I will hit enter. And I should see the same path, if you will. The addresses are different, but I should see the same path. This right here, this router is the FD00A:A:A router. It then hits the Philadelphia router here, which is the A::B router. And then it hits the C node over here, which is this laptop, A::C. We know that's the path it took. There is the same process, but in IP version 6. And again, it's showing me the path I have taken from A to B. I will copy that. I will come over here and I will paste this in. And that was my IP version 6 trace, my IP version 4 and my IP version 6 trace. So again, that is handy if I know the path things should be taking, and I use that. Let's say if there was a problem, it'll show me part way. You know, if I have a broken link over here, this path will get here, and then stop. And then I'll know, oh, okay, I got to this far. We have an issue over here. That's what that would show me. All right, at this point, I'll make sure I'm going to save my packet tracer file there. I'm going to save my text file. And I'm going to make sure I have all the pieces down here. I remind you, I have all the pieces. And I'm going to go in here and I'm going to make sure I have part 1, Ethernet header. I do. Part 2, here's my ARP packet and my ARP table. I got it. Next one, I have my UDP header fields. I got it. TCP, I have the 3 handshakes, 1, 2, 3. IP4, I have the source and destination, my ICMP packets, if you will. Okay. And then same thing with IP version 6, my destination, my IP version 6 header fields for ICMP version 6. I have my netstack command results, and then I have my trace results. And I have them for IP4 and IP6. So at this point, I'll take a minute and make sure I get that text file submitted to the Chapter 4 Dropbox on D2L.